Young people, welcome back. B in the house. You guys know what we're doing? Taking care of Chapter 8, Lesson 4. Learning objective from the textbook. Number 1, find squares of sums and differences. Number 2, find the product of a sum and a difference. So guys, you know how we like to do swap back. Students will be able to basically multiply binomials and of course find the product or sum or difference of them. Let's get this bad boy started, guys. All right, so first thing I want to do is slow it down. Special products, guys, literally just like that, they're special. They should be quite simple and easier. We are pulling in some graphic organizers, as you can see, that we're going to use later on. But starting off with number 1, where we see the binomial n plus 3 to the second power. Just go ahead and write this out. The exponent is touching the parentheses, so I have the 2 sets. I have 1 and 2, n plus 3 and n plus 3. So a final answer, after doing FOIL, first, outside, inside, last. You'll hear that a few times a day. But you don't have to use FOIL. Not my favorite thing to do, but it will be explained here. So, slowing down, we got 4 terms and we added them up and we got n squared plus 6n plus 9. So the number 3 there is the same process. If we got a negative constant, so y minus 7 times y minus 7. And again, y times y. I'm going to show it here. Gives me y to the second power. First term. Y times negative 7. Negative 7y. So that's that first, outside, inside, and last. FOIL. I hated FOIL as a kid. FOIL. What's the use of FOIL? But as an instructor now, I definitely understand it. So we're going to add the 2 middle terms, negative 7y and negative 7y gives me negative 14y. So my final answer, after simplifying the special product there, y squared minus 14y plus 49. So the reason why the graphic organizers are there is because I love the box. That's what I call it. It's got way better names than that. Look them up. But basically, guys, we're going to use the box to multiply. The same way we have multiplication table, you take this times this, you get it in there, and then you go down to the 4 times 5, and go down there, right? So what we're doing now is we are creating a box to answer number 5. B plus 1 times B minus 1. I'm going to do a little quick pause here so that I can demonstrate, point out, or make sure that you guys see that right there on the top of the box is B plus 1. I put the plus because it's a positive 1, right? And then the second binomial, B minus 1, well, right there on the left, B, and then you see the negative 1, right? So 2 squares on the top, 2 squares on the side because I have 2 terms in the first set of parentheses and 2 terms in the second set. So we call that a 2 by 2. 2 on top, 2 on the side. When you get later chapters, 2 by 3, 3 by 3, you'll understand how this box can be helpful. And with that, guys, we're going to multiply, right? So b times b gave me b squared, first box inside that box. B times 1 is 1b, b times negative 1 is negative 1b, then of course 1 times negative 1 is negative 1. So let's get this going again because I'm already showing collecting like terms. Just like in number 1 and 3 where we added 2 middle terms, 3n and 3n up there, and then right here negative 7y, negative 7y. So now I'm going to add my middle terms in the box. Same thing. Let's get her going again. So I'm using the orange or yellow to show my like terms. And of course they cancel each other because the positive and the negative cancel each other, so the positive 1b and the negative 1b. So there's your 4 terms. And again, by simplifying, your 2 middle terms will cancel, leaving you with b squared minus 1. Let's do it again. So we got b minus 4 all to the second power. So say B, I meant P. So P and then -4 on your top, and then P and -4 on the bottom. So fill it in, P times P, P squared. P times -4, -4P, P times -4, -4P, and -4 times -4 is a positive 16. So again, you see I circle my like terms. Adding those up, right there, we got a -8P. So my answer, P squared minus 8P plus 16. Ending up with 3 terms for my answer. Excuse me, for number 7. All right, guys. So I showed both methods. Up in the top with the red and the blue, we have our foil. Hey, foil. First, outside, inside, last. And then, of course, on the bottom section right there, guys, I use what we call the box, like the square. And what you're going to do is you're going to have your 2 terms on top and your 2 terms on the side and multiply the side for what you like terms. All right, guys, so we're going to be using those boxes throughout the lesson. So you'll see them. They're going to stay. They're going to hang out. And remember, guys, feel free to pause at any time, move ahead, check what you got. But I'm getting right into it. Number 9, L plus 2, all times L plus 2. So L plus 2, L squared, 2L, 2L, and 4. We're just filling it in, guys. Collect the like terms in the bottom there, 2L and 2L give you 4L. For the next one, 3G and a positive 2. You see I did not put a positive, a plus sign next to the 2, but I made sure to put a minus or negative with the -2. And again, guys, as you know, sometimes we go a little faster because we got a lot to do. So your middle terms here are going to cancel because a positive 6G and a negative 6G eliminate each other. So leaving you with 9G squared minus 4. So 6 plus U all to the second power. Again, when I see it, it's good for me to write it out. So the binomial is being squared. So that means I have 2 binomials, 6 plus U and 6 plus U. 6 times 6, 36. 6 times U, 6U, 6 times U again. Or I should say U times 6. And then of course U times U. Gotta add your like terms. So 2 middle terms will give you 12U. And again, guys, if you want to put that in standard form, you would start with U squared, then plus 12U plus 36. But you know, we're finding the product. We're multiplying them out. All right, guys, so that first odds are done. This is a great opportunity to give it a pause and try the evens, right? Because you know B&B is going to do them with you. So if you don't pause, you're going to run out of time. Because I'm about to get started as soon as we clean all this up. So like I said, guys, I'm going to keep those squares. The more you use them, the better you get at them. And it's going to help you in your factoring. It's going to help you with polynomials in general. So just something that we use, right? And it cleaned up enough. I guess I can do a little more, but I think that'll be perfect. Here we go, guys. Number 2, going back to the simplicity of x plus 4 times x plus 4, so x times x squared. X times 4 is 4x, 4 times x is 4x, and 4 times 4 is 16. Again, your 2 middle terms, 4x and 4x, add up to 8x. For number 4, again, they're not using an exponent, but it is the same binomial, t minus 3 and t minus 3. So in my brain, of course, t times t, -3 times t, and t times -3. And then, of course, a negative times a negative is a positive, so therefore you get a positive 9. Collecting your 2 middle terms, and again, there's my final answer of t squared minus 6t plus 9. Haven't used the box yet. I'm doing what's called FOIL. If you want to call it FOIL, we'll just distribute property, basically, but we're distributing 2 terms to another 2 terms in a different set. So a minus 5 times the quantity of a plus 5, so a times a. We got it. Now a times 5 is 5a. And now -5 times a, -5a. And of course, the negative times the positive is a negative. So 5 times 5 is 25, but we get -25. Finding those middle terms, and guys, you'll notice it's usually like that. It's gonna be your 2 middle terms. Whether I'm using the box, whether I'm writing it out, I'll see my like terms next to each other if I'm following the same process. So z plus 3 times the quantity of z minus 3 times use box. So z and a positive 3 on top, z and a negative 3 on the left, z squared, positive 3z, negative 3z, and then of course a negative 9. Showing again my diagonals right there cancel each other. So I do collect them, but they just add up to 0. And they go away. So z squared minus 9. For number 10, we're going to use that box again because it's always going to work. It's not going to work if you mess up multiplying inside, but if you label the top of your box, as I'm doing here, R, well, I'm going to do the answer first. But there's FOIL, right? R squared minus 2R plus 1, because I added the negative 1R and the negative 1R. But again, guys, just point out the box or FOIL, whichever method is most comfortable for you. And it looks like I'm getting rid of it because I need some room. Might as well get rid of that other box too because I didn't even use it. Probably got a little annoyed by the blue, sometimes I like things to be just right. So here we go, guys. Looking at number 12, which is the last in this set. 2m minus 3, all times the quantity of 2m plus 3. So again, the first term times the first term. Ooh, I'm pointing out something that's going to come up. So a positive 3 and a negative 3, of course, they're going to cancel out that middle term. So 4m squared minus 9, because again, you've seen it enough, and if you haven't, use the box, right? But my brain at this point, after we've done what? 12 plus. Here we go. 2m times 3 and negative 3 times 2m. Not using the arrows, but you get it. 6m and negative 6m cancel each other, gives you that 0. So that middle term disappears. Every single one we have is disappearing unless your constants are opposites. So you notice the r minus 1 and r plus 1. Even in this one, number 22, 3b plus 7 and 3b minus 7, right? Those are going to cancel. So let's keep it moving, guys, because nothing's changing. This is what I love about this lesson. Repetition, repetition, repetition. Mr. Craft, why we got to do 25 of them? Repetition, repetition, repetition. So r plus t, all squared, gives me r plus t times r plus t. Again, r times r, that's first. I hated it. And then r times t gives me 1 rt. And t times r gives me 1 rt. And then, of course, t times t. So that one is fun, and I love how we're writing it out. Now, will I write it as tr or rt? It looks like I'm putting rt. So it doesn't matter. X, Y, Y, X, S, T. You can move those variables around. So rt and rt add up to 2rt with the invisible one. I'm so glad we slowed down to show the FOIL. For 16, again, looks like we're going to knock it out with a box. Good to go back and forth. You can decide which method is best for you or which one you click to a little sooner, when it clicks in your brain, and that's the one you like, right? But on the top, I got the C and a negative B. On the bottom, on the left, C and another negative B. And this is where the second term of the binomial are not opposites, they're both negative. So I have to add. You see, before I was using the yellow to indicate the middle terms. Here I'm just using a box to show I'm collecting them. So negative 1 and negative 1 give me negative 2, so negative 2CD. And that looks good to me, guys. So again, with 18, still knocking it out. I have a binomial square, special product, right? You start to kind of catch on. I got W squared plus 3HW plus another 3HW plus, of course, 3 times 3 is 9 and H times H is H squared, so 9H squared. Collect those middle terms and you're good. So you notice this time, guys, I didn't even write out the binomial squared. I just went right into it. So same thing with 20 here. With 20, I see t plus 2u to the second power, all to the second power. So t times t. And what do you know? I did write it out this time. So not an 18, but definitely a 20 because I'm here for you. I want to make sure you guys are getting this. So t times t, and then 2tu and another 2tu. Again, ut or tu, don't let it catch you. And then of course, 2u times 2u gives me 4u to the second power. And that's looking lovely, guys, as soon as I collect like terms. So the first term, and the second term, and the third term, and then the fourth term. Well, we've had a consistent of the second and third. The second and the third term are the ones that we are combining to get our final answer, right? Got it. All right, guys, I think I did a great job explaining that. Let's get rid of it. And let's get rid of it a little bit faster. Oh, is this time for questions? Definitely. But you gotta put them in the comments so I can answer them later. All right, guys. Definitely like, share, comment. I'm here for the long run. Let me know how I can get better, guys. And with that said, we're leaving 18 and 19 up there. It's kind of a good reference. As you notice, one I did not write out, but the second one I did. So for 22, I have both binomials. And as I mentioned earlier, the second term in both are opposites. So a positive 7, and then of course a negative 7. Now, the BMB knows something's gonna get canceled. But you want to do enough of these so that when you see a positive 7 and negative 7 as your second term, your brain automatically recognizes they're going to cancel each other. So, looks like I'm playing around, making a fun little box here, I guess. Positive 7, and of course, 3b on the top. On the side, we got 3b and the negative 7. And as I'm making a not so clean box, but it's going to work for us, 3 times 3, 9, b times b, b squared, 9b squared. 21b, and then negative 21b. And of course, like we've seen over and over, those are opposites. So automatically, I recognize from before that with that positive 7 and negative 7, my two middle terms are going to end up canceling each other. So a negative 21b and a positive 21b. And then of course, I still have the negative 49 and the positive 9b squared. So what we get is what's called a difference of two squares. And we'll talk about that when we get to the factoring chapter. But 9b squared minus 49, what how? Now 24 though, what do you see? You see, well of course, just one binomial, squared. So am I writing this one out? Does my brain say write it out, write it out? Or does my brain say knock it out? Well, let's see what I write. I am going to write box. So I don't need to write it out. Just need to put it on the top, put it on the side. I'm good to go. So what's going on the top? Oh, you fill it in the box before you even do the outside of the box. Come on, you know you talk about your kids for that, Mr. Craft. But hey, I'm on number 24. I'm starting to feel myself. I'm getting into this. Let's make it happen, right? So n squared times n squared, of course, gave me that first box into the fourth. R squared times n squared, yes, n squared, r squared. There's more letters than numbers, guys. This is what kids get all frustrated, right? Then of course, again, n squared times r squared, n squared, r squared, and then r squared times r squared is r to the fourth, and what the hell? You don't get no better than that. You prove to your instructor I know what I'm doing. I can make a mistake, but I didn't get this wrong. That's correct. Tell me I'm right. Excellent work, guys, excellent work. So that leaves us with 26, and 26 again, guys, it's nothing different. Let's go ahead and get it in though, because 3t squared minus n all to the second power. I challenge my students to just write algebra. If I were to read that and you didn't see it, could you write it out? Parentheses open, 3t squared minus n parentheses close all to the second power. Boom. What's that mean? It means I have two binomials. 3t squared minus n, all times 3t squared minus n. So I know now 3t squared times 3t squared, 9t to the fourth power. 3t squared times a negative n, 3t squared n. Now negative n times 3t squared, again, is negative 3t squared n. And the last one, the negative times the negative is a positive, so n squared, positive n squared. Collecting my like terms, again, term 3 and term 2, the two middle terms. And of course, boxing a final answer for you. All right, guys, I'm feeling good. I hope you are. This is a skill that is critical in your algebra experience, honestly. When someone starts talking about binomials and trinomials and factoring and squaring and difference of two squares and quadratics, this is what we're talking about. You know, we're talking about you taking the time to, okay, this isn't hard, it's just challenging. So with it being challenging, of course there'll be mistakes, but we've done 26 of these already. And guess what? If you watched all 20 minutes, I know you're learning. You're feeling good. So guys, let's knock this out. We didn't do 24 because I still got some on this side. We got the odds over here. So 17, 2k minus 2, all to the second power. Looks like I'm jumping into it. 2k times 2k. And we're not talking video games. 4k squared. Then of course, 2k times negative 2, negative 4k. And then of course, that 2k times a negative 2 again, negative 4k. And then of course, the negative times the negative is a positive, so we get the positive 4 on the end. Now what I love is, here's that foil. The first terms, the outside terms, the inside terms, and the last terms. And if you're anything like me, it's gonna take you like 15 years or 20 to understand foil. Doesn't mean I didn't pass algebra in high school, and it doesn't mean that you won't either. All right, so what works for you, what works for you. All right, so jumping into 19, 3p times 3p gave me the first term, which is incorrect. Oops, my bad. Everybody know 3 times 3 ain't 3. That's a mistake. Number 19, we found a mistake. This is BMB, I make mistakes, but I don't like it. It's okay. So 21. Let's see, we get this without a mistake. X minus 4y all to the second power. And of course, it looks like I'm slowing down, so x times x was good. Then a negative 4y times x is negative 4xy. And I'll do it again. Negative 4xy. And then of course, negative 4y times negative 4y, positive 16y squared. Ooh, we got the box. We got the box. So the good thing now, guys, is maybe I should have did that with 19, huh? But the box is going to verify that what I did in my head is going to be correct. The graphic organizing, right? So first square, x squared. Second square, negative 4xy. Third one, negative 4xy. And the last one, 16y squared. So yeah, all 4 of my terms that I did without the box were correct. All 4 terms that I did without the FOIL arrows or distributive property arrows, whichever you want to call them, I still did it correctly. So repetition, repetition, repetition to get those mistakes out of your system, right? And of course, calculator. You know, I thought 3 times 3 was 3. Maybe I should have a calculator with it, 9p. All right, guys, having fun like we always do here. So, done with 21, we've only got 23 and 25. I believe that will probably be the end of the handout. Wanted to make sure that as we look at 21 again, that is a binomial squared. Binomial, 2 terms. Now number 19 is a binomial times a binomial. They're not squaring it because you have different terms inside your binomials. So for 23, again, that's a binomial times a binomial. 3y minus 3g, and then 3y plus 3g. So we saw this earlier with our second terms being opposites. That's going to cause them to cancel each other, right? So the first term, 9y squared. Oh, I got it right this time. 3 times 3. 9. Okay, and of course, the last term in that binomial. So 25, pointing out what I was saying before. Now I have a binomial squared. Writing it out. And it's just those little things. Recognizing why I wrote out 25, because I got a binomial squared. 23, no, right now. They're already written out, right? So first term times the first term, 4k squared. Outside times the outside, 2k m squared. And then inside, m squared times 2k. 2km squared. And then of course, last, m squared times m squared m to the fourth. So again, guys, this is why sometimes it's awesome that you have these videos because you can pause it, write these notes. There's 2 burps in 1 video. Whatever I have for breakfast, I'm gonna have it again. We're good. Get out of here. And should we run? I know you run sometimes. Should I run? It's a word problem. We don't run? No, we don't run. Maybe we should run. Let's at least read it. Geometry. The length of a rectangle is the sum of 2 whole numbers. I understand. The width of the rectangle is the difference of the same 2 whole numbers. I understand. Using these facts, write a verbal expression for the area of the rectangle. Sum of 2 whole numbers. I don't know what those numbers are. Let's call them x and y. A sum. So we're adding x and y. My first binomial is x plus y. The length is L equals the quantity of x plus y. Difference means subtraction. We learned that a long time ago. So the difference of the same 2 numbers. So if I'm using x for the first number and y for the second, I gotta use x and y again because it's the same 2 numbers. So the width is x minus y. Got it. How do we find the area of a rectangle? Because that's what they're asking. Use these facts. Write a verbal expression for the area of the rectangle. So area is equal to length times width. My length was x plus y. Scatter this all of a sudden. And then the y, that is here. And x minus y. So x plus y times x minus y. Again, we've done this, guys, where we've had more letters than actual numbers. And showing you again that I recognize opposite terms in the second term in the binomial. So they're going to eliminate each other. And there I am writing it out for you. A negative 1xy and a positive 1xy. And they will cancel each other, leaving me with x squared minus y squared. Guys, you gotta love this. And if you don't love it, you just gotta do more of it. To the point where you might not love it, but you appreciate it because you know it's making you better. Thanks for watching. Can't wait to see you guys in the next video.